Hi, everyone. I'm not sure if you've met her yet, but this is Pearl, and she's fabulous. And she is here today to talk to you about density. Density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. For density, we use the lowercase p, and the formula again is density equals mass divided by volume. You can make a pyramid tree with density, mass, and volume, and if you need to, you can recalculate this based on what you're trying to solve for. Density equals mass divided by volume. If you're trying to solve for mass, mass equals density times volume. And if you're trying to solve for volume, it's volume equals mass divided by density. All right, so we have a few problems here in your note-taking template. Learning target, find the density, mass, given mass and volume. And the formula density is the amount of matter that an object has in a given unit of volume. So the first problem here actually kind of stumped me, and I had to go back and do it twice. The reason being, you'll notice that it has a cylinder of a radius of 24 inches and a height of 32 inches, yet it says the density of concrete is 2.3 grams per cubic centimeter. So we actually have to convert these units to centimeters first, or we can actually convert those are the ones we want to convert. So we're going to first convert 24 inches to centimeters. So this is like a nice one to just use Google for. I Googled inches to centimeters. And so we can actually say, let's go back to that one again. We have 24 inches. So I'm just going to say how, let's do inches to centimeters. So 24 inches is 6.96 centimeters. So you'd multiply the length by 2.54. So 24 times 2.54, 60.96. So this number here is 60.96 centimeters. And then 32 inches, we'll convert that also. 81.28. This is when Google's real nice and helpful and totally fine to use. It was 81.28, right? I'm sorry, I'm writing with my mouse. I can't find my trackpad. I actually can't find the dongle. The density again was that. So we're going to find the mass of the concrete cylinder. So let's scroll up here. Mass formula. That's why these conversions are nice. Mass is equal to the density times the volume. So we'll write that out. Mass equals density, which again was that letter P, times the volume. We do know the density, so this number we know. The volume we don't know. We're trying to find the mass. The volume, though, we can find. We do know that it's a cylinder. It has a radius of our 60.96. Centimeters and a height of 81.28. And so we can look back at our formula sheets. Remember, those are linked, so you can make a copy of it if you want. So volume of a cylinder was pi r squared h. So volume would equal pi times the radius, which is 60.96. Times the height, or pi times the radius squared, times the height, 81.28. So that's our volume. The formula is just mass density times volume. We do know that the density was 2.3. So we're actually just going to take all of this and times that by 2.3, and that should give us our final answer. So we'll plug that all into Desmos. Pi times 60.96. Squared times 81.28 times 2.3. 2182. Oh, 2182. I can remember these numbers. Mass equals 2182,485. And it wanted it rounded to the nearest gram. That's a whole number. So 0.85, that 2 keeps the 5 the same. So that is our final answer. And the answer is that in grams. The next one is also slightly tricky for me. So I decided to go in and read my textbook. Crazy thought, right? And so when we go to our Big Ideas textbook, there's actually a problem that is very similar. Talks about the density of an aluminum can. You want to find the thickness. And so it says here too, surface area times the thickness is equal to the volume. So I'm going to go ahead and write that down. Surface area times thickness equals volume. For later on, surface area times thickness equals volume. So for this one, it does want the thickness of the aluminum. And so we are going to need to find the surface area of this figure and the volume of this figure. And so the surface area of it, we can figure that out because we do know the formula for the surface area of this. And so let's do that first. So the surface area, actually, I'm going to do that. Surface area. And this is a good one again. They're just like wrapping that present, remember, for surface area. But the surface area of a prism is 2 times area of the base times the lateral area. And so really it's just like dissecting that whole thing and finding the areas of all the parts of it. And so we'll go ahead and do that. And so the face of this would be 8 times 4. So the face of this would be 6 times 8, so 48. So that's on the front and the back. This side would be 6 times 4, 24. So this would be this side and this side. And then the top and bottom, 8 times 4, 32. So we're going to do 48 plus 48 for the front and back. Top and bottom, 32 plus 32. So that's 64. And then 2 sides added up, 24 plus 24, 48. So let's add those all up. 48 plus 48. Plus 64 plus 48. 208. That would be inches squared. So that is our surface area, 208 inches squared. And that one also, it's wanting it in, oh gosh, a mass empty is 700 grams. Estimate the thickness of the aluminum. Oh, it does give you the grams per cubic centimeter for the density. So we actually do want to find this not only in centimeters, but also inches. So let's actually go back and convert all of that to centimeters. So really none of that part mattered. Sorry. Boop, boop, boop. Okay, so let's go ahead and select these. Right, that was just a good practice on surface area. So let's convert these 8 inches to centimeters. So 8, 20.32. 4 inches to centimeters. 10.16. And then 6, 15.24. All right, so our surface area. So the front side is going to be 20.32 times 15.24. So we're going to round these. So that's approximately 310. The side would be 10.16 times 15.24. Approximately 155. And then top and bottom would be 20.32 times 10.16. 206 approximately. Okay, so now our surface area, 310 twice, so that's 620. 155 twice, so that is 310. And then top and bottom, 206 twice, so 412. 620, 310, and 412. Forgot it already. 310 and 412. And 342. Centimeters squared. All right. We could find the volume. You could find the volume by using the volume formula, or we can just use this formula to find the volume, which again, the volume is going to equal mass divided by density. So volume equals mass divided by the density. We know the density is 2.7, so 2.7. The mass of the lunchbox is 700 grams. So 700 divided by 2.7. This is an empty lunchbox, so that's why we just want the volume for the empty portion. 700 divided by 2.7. So 259.2, so 259. And then in order to find that thickness, we'll plug those numbers in. So surface area 1342 times our thickness, I'm just going to use that letter big T, thickness, equals our volume, which is 259. So then we're going to divide that by 1342. Sorry about Wrigley. In order to get our thickness. 259 divided by 1342. Our thickness is 0.19. All that for that. 0.19 centimeters, and then you can convert that to inches, centimeters to inches. Just switch this around. It said 0.19 centimeters is 0.07 inches. That one was really fun. Again, be sure and come to live class. We'll be doing more of these together.